It will be uh, most of you guys would have actually already heard of what is human computer interaction, but on the perspective of musical interfaces, music technology will actually show some light. So you know the instrument, it's piano, right? So how do we actually play with it? What kind of actions would you actually just show up playing piano this way? Okay, yeah. So using our motor skills, hand motor, we do this gesture with fine motor skills of dexterity of fingers movements. This is the way we interact with this particular instrument to generate sound or produce sound. And there is an engagement that's getting connected to us, and then something moves on. So likewise, any these instruments, so guitar, we do this kind of, and there is also this particular technique of actually handling or um, using this or interacting with this instrument, particular instrument, is also comes with the physical constraint of the instrument itself, the physics with which the instrument is playing the sound, and how we actually plug or strum the string, because it's a string instrument, and the shape of the instrument itself, it actually feels like we'll have to hold it this way. We can also try different ways as well. So, and let's say tabla, it's always most of the tabla players, they sit on the floor and then they actually play the instrument. And this instrument, some of you would have actually known, it's theremin. It's kind of playing music in air with some hand gestures. Using radio waves, it actually detects and then maps it to sounds. And this is violin with a bow. It's a separate device piece with which we actually, instead of plucking the no, string, we actually sweep on the string. So these are different ways by which we interact with specific instruments, and this interaction actually started evolving since long time. And so when we actually talk about the interaction, basically it's the musical instruments is not just about um, making sound, but also we actually see in the perspective of how the interaction as the interface is actually happening between the instrument and the human player. So so that's how the human computer interaction actually plays a key role in designing a musical instrument. So, and some of the key concepts we actually apply for designing our instruments are affordances, signifiers, mapping, feedback, and mental model. So we might not be having much time to actually explore deep into dive into these topics. So these are some of the concepts that we adapted from interaction design principles. uh, so affordance is basically the way in which how the user and the instrument or a device is interacting with each other. What are the different ways I can actually do something with it, or I can make an action something with it. Let's say this is a microphone, and then it feels like I can actually hold like this. So that's actually happening because of the affordance that this particular rod actually gives me. So, or sometimes I also feel that it's actually wobbly, and then I can also these kind of stuff. So it also gives me these affordances. So likewise, when we explore what are the affordances an instrument can actually give, people try leveraging all different possible actions, and then they expand the degree of expressions that from one instrument a player can actually leverage. So likewise, we try to ideate on different ways of interacting with an instrument, or sometimes even converge on to designing a new instrument itself from scratch. So, and yeah, let's actually quickly go through the works that we have done so far. Now, Kratika will actually.
So, in this, did you guys notice anything that happened right now in the music? Uh, so in this, what happened? The using eye gaze, I just changed the tone of the instrument. So in the beginning, when I was playing this, now from eyes, I'll change the plugin. So we designed this system because whenever you guys are musician, you play keyboards and you play a lot of instruments, and meanwhile you have to change the tones. But sometimes what happens, the music becomes so complex that you don't even get time to change, and you have to practice every time. So we give one assistive thing that you can actually change the tone using your eyes while playing. So this is one thing that we call it like eye gaze tracking and changing the plugins while playing the instruments. So in that, I was playing Riders on the Storm by Doors, and then I was switching with the organ and piano while playing it. So one more time, I'll also do it. Next, this instrument is swarings. This instrument has started as a coursework project where we actually have to design a new kind of interaction, like new instrument based on instrument. If you guys know about NIME, like new interfaces for musical expression, we started with that, and we the idea was actually to have new sort of interaction while making the instrument. So the idea, the inspiration come from the accelerator from a bike or rings. That's why you see a lot of rings here. And when beginning, like when we started, then there is also a small musical problem in MIDI keyboards. Not problem, but the thing that you can't do it in MIDI keyboards. That is, you can't control pitch bend, modulation, and the note like simultaneously. So in this, what happens? This ring has this kind of interaction where this movement is pitch bend and this movement is modulation. You can control the note individually, but also if you wanted to do both of them together, so you have this diagonal movement, you have this circular movement using the rings. These all rings are like 12 notes, basically 13, one octave note, and this is a copper tape that when you touches it, then it controls. So I'll play a short clip of it. So in this, we also give pedals in order to change the octave. What happens whenever you're playing a piano or guitar, whenever you're shifting to the lower frequencies to the higher frequencies, there is a small time that you always take to actually switch from lower frequencies to higher. But we are giving this pedal so that you can quickly change it in a second right now. So this swarings, it started in January 2025, and this is 8th iteration, and we are still iterating it, and it also got published in UIST 2025. Next is so in Indian classical music, we count tals on this da din da, like on the palms, but there are more different, like in Karnataka you do it like on lap, and in Hindustan you do it also like this, but one of the form is you do it like this when practicing. This started as a problem when for Indian classical singers, when they're practicing music, they have to be on rhythm, they have to be on tal, and and they have to find accompanist every time, or either they use metronome. But the old way of, the way they count is like this on the palm. So we give a feedback using a glove, where whenever they are practicing, they're practicing singing, they'll hear a tabla bowl, whatever the tal they are practicing in. Not the complex, it can't do complex, but they can be on beat right now. So there's a small clip of it.
Then, ta, ta, then, ta, ta, then, ta, ta, then, ta, ta, then, ta.
So this is swarings, and this tabla glove are both MIDI device. Tabla glove is wireless, and it can be connected to any DAW, both of the instruments. And next is this project has a lot of POVs, like different. When we started, we just thought it's a we actually tried something gravity well. Do you guys know gravity well? Okay, so gravity well is like just simple concept where center mass in the middle, and when you project the planets, that moves around the center mass, and when the if the mass is
Basically, yeah. Sorry, I will take it. So, gravity well is a way with which physicists, they actually illustrate or demonstrate how gravity works in Einstein's way of actually, relativity. So, basically, gravity, it's not a push or pull force, but rather it's a motion change due to the curvature present in the space-time continuum. That is his proposal. So gravity is not a force, but rather it's an effect of a defect that actually is done by the mass that is being present in the space-time. So for that to illustrate, they actually put a fabric, a cloth, and then they actually place a huge mass at the center, thinking that that's the star, that's a center of, let's say, solar sun. And then when we actually throw a few balls of different masses around it, it tries to actually, because of the curvature, it tries to actually spin towards the center. But here there is gravity also is involved already. Newton's way of explaining also can be done, but to illustrate the quantum level of how the gravity is working, we generally physicists, they actually illustrate on. Using this, she actually proposed an idea of, can we actually sonify the movement of the balls. Yeah.
Of the balls. So the sound, we'll check the video and we'll actually explain each of the things once. So this one was the Nebula preset. One thing is, this is the well. We placed a camera in top of it, and we were getting all the data like x coordinates of the well, y coordinates, angle from center, and all the data. And we were actually processing into the Max. First, we run a Python script using OpenCV, and then send the data to the Max using OSC, and then sonify the data based on some small concept. Like nebula is a star that expands in x-axis, so we put it like reverb. Similarly, y-axis is something, angle is something. Like that, we actually did the sonification of this. And next, come to the next preset. Yeah. So in this, we started with a wave. We can select any wave, saw, sine, and then based on the ball's location on the well, wherever we are projecting, it will actually sonify the data. That's how. And last one is interesting. That is. So in this there's a like Kepler has already set some laws related to universe and music. So one of the law was when the mass is near to the center mass, like the planet is near to the center mass, it will sound higher in pitch, and if you're going relatively lower, like back, then it will sound lower in pitch. So we use this law, like if the ball is near to the center mass, it will sound higher and then relatively lower. And then after that, we used different sorts of scales in this, like we used Indian classical ragas, like ascending, descending, because they have sometimes different like rag days. And we also use major scales. Fun fact is with C harmonic minor, we tried to play it, a Harry Potter theme song, something it was coming okay, okay, like a background of BG, and like that. It was not intention to actually make it, but just to experiment how it will come out and how the sonifications can work out with gravity well. And one more thing, when you're talking about interaction, most of the instrument you see, you have interaction like full control or half control on it. But in this well, like you see, half control is with the user. I can project the ball anywhere and it will obviously produce different sound whenever I'm projecting. It's not algorithm, it's based on location and wherever we are projecting the ball into this sphere, like gravity well. Next is hand. Okay.
Yeah. And also a shout out to our team members, and one of our close coordinators, Alvin, is also here. So he was also part of Gravitone project. So we actually demonstrated. Kratika went to Canberra last year to present this work. Yeah.
And this is last, like how the using the hand motion. You guys know about Rolly Seaboard, Rolly's airwave, right? Similar kind of thing we did using leap motion, mapping the hand gestures to modulation and all. Yes. And this is our team Hive. Like we do everything. This like Gautam sir can tell more.
Yeah. So HIVE stands for Harmony Interaction Versatile Exploration Lab, which we started by 2023 beginning at Department of Design, IIT Kanpur. So a shout out to our guys. So some of the people here you can see are closely associated with music technology. We also started music tech hardly maybe 1.5 years ago.
Yeah.
Yeah, so that's how we are. And we also, I mean, yeah, where is the, yeah. So you can actually check out our handles. You can please follow us. And just to get to the academics part of it, we also introduced a course on sound design and music technology from this year onwards. So there is a course that's going on right now. So In India also we have started now. So hoping, and we are closely uh, collaborating with Prashant, Alvin, and many of us here. So they're also giving guest lectures and training our students. So, and yeah, thank you guys.